Nicotine is a nitrogen containing organic compound. The percentage composition of nicotine is 74.0% carbon, 8.7% hydrogen and 17.3% nitrogen. The question further says that if the molar mass of nicotine is 162.0 gram per mole, what is its empirical and molecular formula? Empirical formula tells the smallest whole number ratio of atoms in the formula, and molecular formula tells the actual number of atoms present in the formula. Let's calculate the empirical formula first. Here the question says the percentage composition of different atoms. Different atoms present in the nicotine compound are carbon, hydrogen and nitrogen. And if we combine all the percentage of these atoms, it should reach 100%. 74.0 plus 8.7 is equal to 82.7, and 82.7 plus 17.3 is equal to 100%. It means that the percentage of carbon present in the nicotine compound is 74.0 out of 100%, or in other terms we can say the mass of carbon present in the nicotine compound is 74.0 gram out of 100 gram. Similarly, the mass of hydrogen will be 8.7 gram and the mass of nitrogen will be 17.3 gram in the compound. Well, here we know the mass of these different atoms. Well, carbon has 74.0 gram mass, and hydrogen has 8.7 gram, and nitrogen it has 17.3 gram. Now we convert the mass of these atoms into moles, and to convert mass into moles we divide the mass by atomic mass of these atoms, and atomic mass of these atoms can be found in the periodic table. And the atomic mass of carbon is 12 gram per mole. Atomic mass of hydrogen is 1.0 gram per mole, and atomic mass of nitrogen is 14.0 gram per mole. Now we can do the division, and for the division we use the calculator. 74.0 divided by 12, and the value we get 6.166. So we can round out this figure and we get the approximate value. Here we have 6.17 moles. Well, when we divide 8.7 by 1, we get 8.7, same value, moles for nitrogen part, and for for hydrogen part, and for nitrogen we divide 17.3 by 14, and the value we get 17.3 by 14, the value we get 1.24. We can round out those figures, 1.24 moles. Here's the mole ratio between among carbon, hydrogen and nitrogen. We have carbon, hydrogen and nitrogen. We have 6.17 is to 8.7 is to 1.24. Now we find out the simplest mole ratio among these atoms, and to find the simplest mole ratio we divide these numbers by the smallest numbers. The smallest number is 1.24. Here we divide 6.17 by 1.24, 8.7 by the same number. Here we have 1.24. Well, now we use the calculator for the division, and we divide 6.17 by 1.24, and the value we get, we can round out this figure. 4.97 is given here. We can round out this figure, and the approximate value we get 5. Here we have 5, and 8.7 is divided by 1.24. 8.7 is divided by 1.24 and the value we get 7, and obviously we get 1 here. Then here you can see that the number of different atoms are shown here. Carbon, there are 5 carbon atoms, there are 7 hydrogen atoms and 1 nitrogen atom present in nicotine compound. The empirical formula will be empirical formula of nicotine compound is C5H7 and there is only 1 nitrogen atom. Well, the question further says that we need to calculate the molecular formula of the compound too. And anyways, we are given the molar mass of nicotine, that is 162.0 gram per mole. First of all, we calculate the number of moles. Here we calculate the molar mass of this empirical formula. We know that the atomic mass of carbon is 12. There are 5 carbon, that's why 5 multiplied by 12, plus there are 7 hydrogen and atomic mass of hydrogen is 1, plus nitrogen has 14 atomic mass. Now we can do the calculation. 12 5 is 60 and here we have 7 and here we have 14. 14 plus 7 is equal to 21 and 21 plus 60 is equal to 81 gram per mole. Now we find out the number of moles by dividing the molar mass of nicotine by the molar mass of empirical formula. N is equal to, we get the molar mass of nicotine is given 162.0 gram per mole, and here we have the molar mass of nicotine is 81 gram per mole, and if we divide we get 81 to the 162, N is equal to 2. Now we apply the formula to calculate the molecular formula. Molecular formula is equal to, it is N bracket empirical formula, and value we have determined, that is 2. We can plug in 2, and empirical formula we know that is C5H7 and N. Now we can open the bracket and we can multiply 2 inside. So here we have C, 5 to the 10, 7 to the 14, and to this is the molecular formula of nicotine compound, and this is the empirical formula of the compound.